All right, good afternoon, everyone. Thanks for joining us today. Let's start with a quick game of real or generated. How many of you think this is a real image? Quick show of hands. Some hands. Okay, some of you there. How many of you think this is a real image? Okay, I see a few. Okay. So the one on your right is actually a generated image generated using Adobe Firefly, which is Adobe's GenAI service, using that prompt over there. And one on your left is actually a real image picked from Adobe stock. And given how the generated image, how realistic it is, sort of goes to show how far we have come along in GenAI journey in, I would say, a relatively short amount of time. My name is Rakshit Rao. I'm a Senior Solutions Architect at AWS. And today I'm joined by Jens Enow from Adobe, and we'll talk about how you could build a Gen AI service like Firefly on AWS, and Jens would share his experience building Firefly on AWS. So when we talk about Gen AI services, and depending on where you are on your Gen AI journey, you have all these different services that AWS offers that you can pick and choose from, right? And we see that as being in 3 different layers, and each of these layers equally important. So on top, you have these applications and services that you could use out of the box and get benefits from Gen AI capabilities without worrying about the underlying large language model that it's using. So for example, you're trying to build a customer solutions or a customer service chatbot into your customer service workflow. You could use Amazon Q, and Q can learn from your internal company's knowledge base and respond to your customers' queries, right? And if you needed access to some very specific large language models, which is the middle layer over there, you could use Amazon Bedrock. And Bedrock gives you access to a large number of large language models. So for example, you can use Anthropic's Cloud, Mistral's AI models, Meta's Llama. And a recent feature that we in fact just launched yesterday is called custom model import. And with this feature, you can even import your own customized models into Bedrock. And with Bedrock, you access these LLMs using APIs, so you do not have to worry about hosting these models or scaling it. Bedrock takes care of that for you, right? And the layer on the bottom is the infrastructure that you need to build and train foundation models. So if you are in the space of fine-tuning or building new Gen AI models, this layer is important to you. And we're going to be talking about this layer in the rest of the talk. Can I get a quick show of hands? How many of you work in the space of building foundation models or large-scale training of ML models? All right, okay, I see a few hands here. So I think you could relate to some of these challenges that come with building such a large-scale Gen AI service. So, and the first one's the most common one that we hear is getting access to that right hardware. And this could be, and this is not just your GPUs or CPUs, right? You need the right storage service, you need the right networking service, you need the right orchestration service to make all of that underlying hardware work together. And the second challenge that we hear often is around scaling, right? So it could be during your training phase where you need access to a large amount of hardware for a few weeks or a few months, and then you need to let that hardware go. Or it could be during your inference side where you have to scale up based on your user demand and then scale down as your user demand decreases. And finally, cost, right? As your Gen AI service gets more and more popular, your costs go up and you need to get a grip on that cost. So let's look at how AWS can help you with some of these challenges, starting with hardware. So getting access to that compute is super critical to building any Gen AI service. And on AWS, you get this largest selection of accelerated instances that you can get on cloud. So for example, on the training side, we have the P5 instances, and these are powered by NVIDIA's H100 Tensor Core GPUs. And the P5 instances are designed to support and deploy some of the most demanding large language models or even diffusion models. On the inferencing side, we have the G6 and the G6E instances, and these are also NVIDIA-based instances. And these are suited more for your fine-tuning or your inferencing use cases. Now, along with making GPUs from our partners like NVIDIA available to you, AWS has been investing in building and manufacturing our own GPUs as well. And for training, for example, we have the Trainium series of silicon, and you could use this and get up to 50% lower cost on your training spend. And on the inferencing side, we have the inferential chips that you could use to reduce your inferencing cost by up to 40%. Now, and these AWS chips have a bit of a different architecture, but if you're interested in those cost savings, you have that option as well, right? And we continue to expand this as more and more GPUs become available. We increase that choice that you have with compute on AWS. So when you're building a GenAI service, the dominant cost tends to be the compute. The GPUs make up most of the cost. So it's super critical to make sure that storage that you have can deliver the data as efficiently as possible to your GPUs. And this means, for example, on AWS, you could use something like Amazon FSx for Lustre. So Lustre is a very popular file system in HPC or high-performance computing or in the machine learning world. And FSx for Lustre is a managed service that you could use on AWS. And Lustre provides you millions of IOPS, terabytes per second of throughput, and all of this by keeping those latency at sub-millisecond levels, right? Another option you have is S3, Amazon S3. Quick show of hands, how many of you know S3 or heard of S3? A lot of you. Expected, it's one of the first and the most popular service that we launched, and we continue to innovate here, right? So we recently launched the X3 Express One Zone storage tier, and this is a completely new storage tier that can offer you up to 10 times faster first byte latency when you compare that to S3 standard. So for example, S3 One Zone will offer you a single-digit millisecond latency when it comes to delivering that first byte, right? So, and it's super critical to have such a storage system that can keep your GPU saturated so you get that best out of your GPUs. Now, you could also use the two of them together, right? For example, when you're doing your training and you're checkpointing your training. So your most hot and the most recent checkpoints can go to Lustre, and then as your training evolves, you could then tier those checkpoints from Lustre onto S3. And so you have a couple of options there and get that best out of your GPUs. Now, along with having the storage and the compute, you also need other tools and services to make up that entire stack you need to build, train, and operate a GenAI service. And this slide sort of gives you an overview of all those services available to you on AWS, right? So we did talk about compute, we talked about storage a bit already, but you need that right networking backbone that can enable that communication between your GPUs at sub-millisecond level. And this is where EFA or Elastic Fabric Adapter can help you. So it supports that high throughput and low latency between your communication between your GPUs, and something that's super important to build a GenAI service. And layer above that is orchestration, right? So now you have all the storage, you have all this compute, you have all this networking. How do you make all of this work together? You could use one of our managed services like EKS or ECS. EKS is Elastic Kubernetes as a Service, and this is a managed Kubernetes as a service on AWS. Or you could use ECS, which is Elastic Container Service, which is our opinionated way of running containers on AWS. And finally, on the top layer, you have all the software and services that you could use to get started with building your GenAI models and build that service, rather than focus on how that underlying hardware works together. So, and we continue to evolve this as well, making more and more software and solutions available to you to help you get started with building that GenAI models and operating that at scale, rather than focusing on the infrastructure itself. The next challenge is around scaling, right? So scaling could be during your training phase, where you need to train a model that's trained on billions of parameters. Or it could be on inferencing side, where you're getting like millions of requests from your end customers. So how could AWS help you here, right? Now, you could use these P4, P5, and Trainium instances as a single instance, but to reasonably train such a large-scale GenAI model, you need multiples of them. And this is where Ultra Cluster can help you. And this is a diagram that shows how we think of an Ultra Cluster. And each of those orange boxes down there is a single rack of compute. And this could be a P4 or P5 or a Trainium. And they are designed and they're co-located in such a way that they are in the same data center, interconnected with a high-performance network that can communicate with each other, or rather that allows these racks to communicate with each other at full bandwidth. And the placement of these compute is done in such a way that the latency to those storage services, those FSx for Lustre and the S3, is as efficient as possible. And now you get access to this cluster out of the box on AWS so that you can start with those training tasks, those distributed training tasks using such a cluster, and don't have to really build any of that. Another option you have is Kubernetes, right? Now, where does Kubernetes really fit into the whole machine learning journey? So if you are, say, for example, done with the local experimentation of a model that you're building and now want to expose that to that large amounts of data that you have, you could package that as a container and give it to Kubernetes. And Kubernetes would provision those GPUs that you need and then deploy that container on the cluster and take care of scaling. Well, that's say on the training side. On the inferencing side, it's actually Kubernetes. The scaling challenges are very close to what Kubernetes was initially designed for, right? So as your user demand increases, Kubernetes scales up, and as your user demand decreases, Kubernetes would scale down. And in both training and in the inferencing side, Kubernetes would also take care of error handling. So GPUs fail, that happens, but Kubernetes will detect it and replace them with a healthy node and make sure that your training or your inferencing job continues without any manual intervention. Now, one of the problems with Kubernetes that we often hear is that managing the control plane of Kubernetes is a bit of a heavy task. And this is where EKS or Elastic Kubernetes Service can help you. So EKS is a managed Kubernetes service as on AWS. And this slide sort of shows you all the different features that are available to you that are specific or that are relevant to machine learning, right? And for example, on the compute side, we take care of hosting the control plane of Kubernetes, of course, and we take care of auto scaling as well. Now, another benefit that you get with EKS is that regardless of how big your cluster is, be it tens of nodes or thousands of nodes, we always charge you that same 10 cents an hour. So you also get some cost benefits going on with EKS as well, right? Now, on the storage and the networking side, we build drivers, we build plugins to make EKS work with those underlying services like FSx for Lustre or EFS, or maybe even the networking side, the EFA or the Elastic Fabric adapter, to simplify that whole interaction that your container on Kubernetes has with the underlying infrastructure. And if you want to learn more about EKS and how you could get benefits from EKS and Kubernetes with machine learning, there's a talk that's happening right after this in Theater G. Highly recommend that. And finally, cost, right? So now we did touch upon costs a bit already. So we talked about Trainium and inferential chips in the context of compute, so which can reduce your training cost by up to 50% or inferencing cost by 50%, 40%. Or you could also, we also talked about those storage services that can reduce your storage cost and also keep your GPU as efficient as possible. We talked about Kubernetes in the context of scaling, but something that Kubernetes is really good at is very efficient utilization of your hardware. So, and if you're using EKS as the control plane, you get that additional cost benefits as well. Now, another aspect that I want to touch upon on how you could save cost is the way you provision your GPUs. Now, and these are some of the options that you have today. So for example, you could use ODCRs or on-demand capacity reservations. Now, using ODCRs, you could essentially get access to any amount of capacity in any availability zone for however long you want. Another option is spot instances. Now, spot instances offer you deep discounts when you compare that with on-demand compute, and with a caveat that EC2 can reclaim that capacity at any time. Now, if your workloads, if your models can handle these reclamations from EC2, then spot instances offer you a good option to save some cost. A new provisioning method that we've recently launched is capacity blocks for ML. Now, this is a relatively new feature that was designed specifically for you to a way to provision GPUs, right? And I want to talk about capacity blocks a bit. So it sort of works like how you book a hotel room when you're planning a vacation, right? So you give a date window, you give a number of instances that you want, and then you give a time duration you want those GPUs for. And EC2 will come back and tell you when the capacity is available. And then you can now go ahead, make the reservation right away, and you're now now sure that that capacity would be available to you at that future point in time. So this helps with the capacity problem. So, but how does it really help with saving cost? So if you're running a GenAI service at scale, this is typically how your capacity requirements look like. You have that baseline capacity that you always need, and then you have spikes every now and then. But there is a scarcity of GPU that's going on in the market, and that's real. It's getting better, but it's still there. But you want that predictability in whether that GPU would be available to you when you actually need it, when you need those spikes, right? And which is why a lot of our customers tend to hold on to those capacity at that blue dotted line over there. What that means is there's a lot of wasted capacity. You hold on to capacity that you need, but that you don't need, but you still hold on to it because you're not sure if you will have that capacity in that future. And this is where capacity blocks can help you. So instead of holding on to that at that peak levels, you could then, instead you could hold on to your GPU capacity at that baseline level, and then use EC2 capacity blocks only for those few spikes of capacity requirements that you have every now and then. Well, a good example of when you can use this is, say you have a GenAI service that's running, and every few weeks or a few months, a year, you need to retrain your model or retrain your model with new data or fine-tune your models, right? And this is where you could use capacity blocks for those few weeks that you need that capacity for, and be sure that you will have that capacity. So these were some of the ways that AWS could help you with building a large-scale GenAI service. And I want to hand over to Jens now, who will talk about Adobe's experience building Firefly.
Thank you. Wow. So many good things already. Yeah, I'm Jens here talking about how we at Adobe leverage a lot of the things you just heard about, right? And I want to start with a slide I used a couple years ago talking about Glacier Instant Retrieval as an option to save storage costs. This picture has been taken in the Arctic Circle in Finland. Actually, hundreds of pictures I took that night. It was very, very cold. You've been like rugged up in these overalls because minus 15 degrees and below. Lots of gear involved, right? So you travel there, you hope, a lot of luck, that there is a clear sky so you can actually take one of these pictures. So what if you don't need to do all of this anymore? You can just go and generate such a picture in seconds, right? And you see the prompts. In the presentation, you will see more of these pictures I put in, and it's usually the first prompt I put. So this is what you get right out of the bat without like fine-tuning and changing it to proof. So this will be revolutionizing the market, that's for sure. But in case you haven't used any generative AI solution for images yet, let me roll a little video to give you an introduction what it actually can do.
Future looks like wow. Oh wow. It's like wow. Yeah. Future looks like wow. Oh wow. And it starts right now. Yeah. Future looks like wow. Go and get it, go and get it, go and get it, go. Go and get it, go and get it, go and get it, go. Go and looking like how? Wow. Wow. The future looks like wow. And it starts right now. It's like wow. You should do this, yeah. It's a brand new future. Wow.
Okay, now you know what we actually do at Adobe Firefly. Any one of you, quick show of hands, have used Adobe Firefly or any other generative AI technology? Okay. Anyone in charge of running generative AI in production? Okay, there's a few hands. Okay, great. So how do we build it? I want to give you a bit of a story around like what it took and what we experienced in the past year, because Firefly just got 1 year. Every developer at the company can go and quickly, rapidly develop a new service, a new feature, which we then can offer to our customers. It gives you a simplified developer experience. It is cloud native. We actually do have it on-prem as well. It's a security compliance built-in, like all the gotchas you need. Right? So you get it kind of right out of the bat, you can start. This platform is in the works for many, many years. And at some point, we thought about how do we can get this platform more reliable, more efficient. Right? So we migrated from our very own custom-built Kubernetes stack to EKS. And you heard that before, what Rakshit was talking about. There's a lot of gains from this. Right? You want to make sure you put your attention to the things you really want to deliver to the business. We don't want to run etcd, right? We don't want to manage API server latency all the time. So we migrated all of our clusters to EKS. We improved the developer experience even further. We could offer new features. We have even more capacity. It's fully supported by AWS, right? So it's a win for everyone. More cost efficiency, as Rakshit said. Better resiliency and scalability for sure. Now, you want to build something like GenAI. Like you have this awesome platform, and you kind of reiterate about your key requirements for this platform. Obviously, in that space right now, velocity is key. You need to go and develop as fast as you can because the market is developing as fast as it can. So the business wants it now. It's always the case, right? No surprise. If you ask, the feature needs to get out to the customers as quick as possible. We still require a mature solution because we offer it to our customers and they're used to something very, very good, right? So no to low code is another intention we have. We want to kind of abstract all of the things you need to do to run this in production away from maybe the researchers or the application teams who actually built this. So and then there is this time to market consideration, which kind of clubs together all the other things we just discussed. And it's an evolving space, like you need to be fast. So we asked ourselves, is Ethos the right solution? And eventually we said, yes, it is, because it's solving a lot of problems for us. And we went with Ethos and get started with Firefly, building our super AI highway on Ethos on our platform. So we launched it in production. It's a great success, which is awesome. But as it happens with things which are a great success, platform gets under pressure, which is not an easy thing to resolve because you can't scale GPUs as you can with CPUs. We're all used to be able to scale in the cloud by just adding some numbers, and you just get instances shortly after. With GPUs and GPU scarcity, it's a little different. Right? So we had to work with AWS. At this point in time, we had been on P40Es. I will come back to this topic a few more times to identify where we have capacity on this planet. Right? We deployed new clusters. There, again, Ethos and the platform and EKS came to the rescue. We started to use on-demand capacity reservations. And also, we collected available instances. So I'm sorry if you put out a workload on Friday and turned it on, and Monday you couldn't start. Maybe we took these instances for you. The interesting thing here is we had to go where the capacity is. Usually, we try to go where the customer is. You want to bring your data as close to the customer, right? So you have low latency. This was a total different pattern. We just had to go where the hardware is, deploy the services, and use it where we can. So from that journey, we learned a lot, and we thought, we need more reliability engineering. We need more SREs on this project as well. So we identified 3 top challenges. One is the deployment time, the lead time to production. And you can see I highlighted the faces in this image aren't looking good, right? So there's always new versions of the models which are constantly being trained and optimized and be delivered to production. And also actually very funny that Firefly thinks that engineers are putting out fires with laptops. I mean, that's what we do, right? We engineer around, we just take a laptop and put out the fire in the data center. So one of the challenges, again, high frequency of deployments and the startup time. Like we're downloading big models into machines running in pods, and we frequently update them, so we have to make sure it's as fast as possible. And you heard some of the things you could use from Rakshit before. So demand and capacity. It's kind of unknown like how good a feature going to be used, how often, how frequently people will do inference. Right? And GPU insights is another thing we looked into. Like we want to understand what's happening with the GPUs. Going back in time, when I was building a gaming computer, I was interested in GPUs. I lost that interest. Today, this is like a valuable thing to have. Like you have to rethink about actually what is a GPU, like how does it work, what limitations it has, because you optimize. From the SRE perspective, we also did the typical things you would do for a normal service, like observability, high availability, reliability. We took care of the secondary infrastructure, all the belongings surrounding this solution, and we also had to spread knowledge. And don't underestimate that. That's a very new field. There's a lot of things you can do. It's explore, but you have to get the knowledge for a lot of these things. It's not a standard thing anymore. And we're still looking into other opportunities to do like some chaos engineering and really make the platform even more reliable. So we continue to adjust on our journey to the GPU scarcity. As I mentioned, we have the migrating to the multi-region setup, take what we need. We also figured out there's other GPU types we might be able to use because they are more available. So we migrated from P40Es to the G5s. Total different approach. We had to retrain the models. So there's pressure on like how do you prepare your models for production? You constantly have to keep up with this as well. Like your entire delivery pipeline needs to be built and quick to kind of support all of these changes. And there's like simple things like actually you have to make sure the models fit into the memory, right? Because it might not be the case because the different instance configurations you can choose from. And we dig deep into GPU observability. In this case, there is an example of using the NVIDIA DCGM to Prometheus, like exporting a lot of metrics. And we found out we can actually look into the power consumption, which is kind of interesting to understand like AWS's power bill for our GPUs. But we also have the temperature and the memory temperature. And you're like, oh, these are nice metrics, like good to have them, maybe. Turns out it was super important to have them. We noticed that running the bleeding edge, putting lots of pressure on these GPUs, that some of these GPUs actually might get into trouble in some cases. So we couldn't really use one of the cores anymore. And then we started debugging. Typical thing, like is it the unit or application? Is it something in Kubernetes, something in NVIDIA, drivers, in the underlying host, or something in between, or a mix of everything? Right? Eventually we figured out it's a slightly higher failure rate than we expected, and we had to prepare our application for it because we weren't expecting it from the CPU workloads. It just works all the time. And there's a lot of learning, and you need to be prepared for these things. So think about it. We scale up the service, we continue to scale, we continue to monitor, we identify these topics, we bring them to better reliability for the application. So what happens next? Rakshit had the cost topic on it, and I have it here as well, because efficiency in generative AI is a topic. So GPUs aren't cheap, and I really love the prompt here with the data center out of gold nuggets. If we do a production inference for Photoshop, it gives you 3 variations to pick from. Right? It's 3 times the exact same prompt we send to the clusters and get the data and present it to you as a user. For Firefly Web, it's actually 4. So we haven't even talked about all the stuff we do in data processing and training before we even do inference. So there's a lot of capacity you need to build such a service. So we settled on some of the key indicators, and like images per second, you would say it's kind of a common one, right? So it's something like requests per second, just in this case, it's images. It helps us quite a lot to understand how we, as a company, as Adobe, offer images to our clients, to our customer applications. Right? There is multiple applications. They all can use a set of models, partial models. And this is like, we can dive into like, who's using what, how much are we expecting from maybe a new product launch. And then cost per image. Really want to drill down into how much we spend on a certain feature. Right? Maybe that is skyrocketing, we don't even notice, but you will notice certainly for the cost. Because this all drives your solution and the total cost of ownership at the end. And you might want to have some inputs for optimization, this giving back to research and say, look, your model needs a bit of tweaking. So we continue the journey on learning about things we wanted to change. So we changed the way we process, right? Before we had requests coming in, just being processed. Now we kind of queue them and look for free workers because we want to go into reconfiguring our clusters at runtime and say, look, like the demand curve is changing. So we're going to balance the number of models of a certain type in the clusters going forward. We're looking into inferentia because it has better availability, but we also need some performance improvements here on our own stack. And now we're transitioning again, and I put this the message down saying like, hey, let's make a transition or a migration every few months. That's literally what we did in the past year. Like every few months, we transitioned from an old architecture to a new architecture, GPU-wise, software stack-wise. It's a constant journey, and you really need to prepare for being able to do that. Rapidly develop further. So let's recap a bit. Build on top of an easy-to-use tech stack. And you're here today. You heard there's a lot of options. There's going to be the other talk later. There is a great tech stack for you available. You can use it, start building on top of it. But please go ahead and plan your capacity. The GPU scarcity is real, and it might hit you, especially if you have to rapidly scale up. It's not CPUs anymore. Develop a hardware strategy. So we're talking cloud, and we forgot about the hardware because it's super easy. It's all software. You can just go, define it, and you get it. It's different with GPUs, at least for the next few years, I would say. It might change. And invest into your observability stack and take into the efficiency component, right? It's not only about like how quickly you can generate, it's also how much you have to pay for this. And look into this from the model and graph performance, all the things you do to get something like this picture to your end users. And yeah, finance, right? They want to know what you're doing. They want to see progress. And I can tell you, it's not a fun experience to have a Monday late night meeting with finance every week, checking in on some of the metrics, right? And saying like, hey, how are they improving? What are you doing? Like, what is the spare capacity here? They want to know and understand. And lastly, prepare for surprises. There will be surprises that could be good or bad, but you really need to prepare. Like everything I told you about preparing your entire stack, building your architecture, there will be a surprise here and there. Okay, and with that, there is a call to action for you all. You have great technology at the fingertips. Have fun building in a very evolving space. That's actually the same prompt for each of the picture. It's just a different configuration, like the style I asked. So you see what's possible, and I would love to see what you can build with this technology. Handing it back off to Rakshi.
Thanks, Jens. That was super insightful. So, thank you. If you want to learn more about how EKS could help you, here's some more resources or even capacity block for ML. If you're new to AWS, highly recommend Skill Builder. This is where you can get access to a lot of training material, hands-on labs. And finally, I want to thank you all for joining us today and request you to fill the survey as you leave, and have a great rest of the summit. Thank you.